Hi, welcome to Step 2 Maths. In this section, we are going to discuss about arithmetic progression. What is sequence? We can arrange numbers in different manner. If we arrange numbers in a particular order, that arrangement is known as sequence of numbers. The most familiar example is set of natural numbers 1, 2, 3, 4, 5, etc. Here we arrange numbers in a particular order, and each number in this sequence, this particular order is known as sequence, and each number in this sequence, they have a specific position. The first number in this sequence has first position. 2 is the second number in this sequence, so its position is 2. Similarly, 3, 4, 5, they have a fixed or specific position in the sequence. Here we have different sequences. The second is 2, 4, 6, 8. The sequence of even numbers. Consider the third one, minus 3, 2, minus 1, 4, minus 7, 10, etc. This is also a sequence of numbers. 5, 5, 5, 5. This is also another sequence. If we arrange numbers in a specific order, that is known as sequence. Each number in the sequence is known as term. 1, 2, 3, 4, 5, etc. This is a sequence, and 1 is first term in this sequence. 2 is second term. Each number in the sequence is known as term. Consider the second sequence, 2, 4, 6, 8. Here 2 is the first term, 6 is the third term, 8 is the fourth term. Each number in the sequence is known as term. Here 1, 2, 3, 4, 5. What is the next term? 6. 2, 4, 6, 8. So what will be the next term? 10. Sequence of even numbers. 5, 5, 5, 5. The sequence of number 5. So the next term is also 5. But consider this sequence, minus 3, 2, minus 1, 4, minus 7, 10. The numbers, first term is negative number, second is a positive one, third is negative. That is, this is also a sequence, but we can't predict what will be the next term. In these first two sequences, consider two consecutive terms, 1, 2. These are two consecutive terms or two neighboring terms. Consider this sequence, 1, 2, 3, 4, 5, 6, etc. Each number is known as term. They are represented using T. First term is T1, second term is T2, third term is T3, etc. Now consider the difference between these two consecutive terms, 1 and 2. That difference is T2 minus T1. difference between two consecutive terms. Next, 3 minus 2, that is T3 minus T2. 2 minus 1 is 1, 3 minus 2 is 1, 4 minus 3 is also 1, 5 minus 4 is 1. So, the difference between the consecutive term is constant. Consider the second sequence 2, 4, 6, 8. 4 minus 2 is 2, 6 minus 4 is 2, 8 minus 6 is also 2. Here also the difference between the two consecutive term is also constant. Consider the fourth sequence 5 minus 5, 0, 5 minus 5, 0. Here the difference between consecutive term is 0. In these sequences 1, 2 and 4, the difference between two consecutive term is constant. That type of sequence is known as arithmetic progression. The terms in that sequence follows a particular order and the difference between the consecutive term is constant. That type of sequence is known as arithmetic progression. In short form, we can write it as AP, arithmetic progression. And the constant difference, that is the common difference, that is represented using the term D. D is equal to T2 minus T1 or T3 minus T2, etc. Consider the third sequence 20, 15, 10, 5, 0, etc. Here the numbers are in decreasing order. Now find the difference between two consecutive numbers. T2 is 15, T1 is 20. The difference D is T2 minus T1, that is T2 is 15 minus T1 is 20 equal to minus 5. Similarly, T3 minus T2, that is 10 minus 15, that is also minus 5. 5 minus 10, minus 5. 0 minus 5, minus 5. In this sequence also, the common difference is a negative number, but it is constant. So, this sequence is also in arithmetic progression. That means the value of the common difference or D may be either positive, negative or 0. Consider the fourth sequence 5, 5, 5, 5. Here also this is also a sequence and the value of D, common difference is 0. That is, the value of D may be positive, negative or 0. If we arrange numbers in a particular order or they follow a definite rule, that set of numbers are in sequence. Each number in the sequence is known as term. They are represented using T1, T2, T3, etc. And if in a sequence, the difference between two consecutive terms, that is T2 minus T1 equal to T3 minus T2, that is also equal to T4 minus T3, etc. That is, the difference between consecutive term is constant. That type of sequence is known as arithmetic progression. The value of D, that is common difference, that may be positive, negative or 0. 4 sequences are given. We have to identify whether the given sequences are in AP or not. How we can determine whether a given sequence is in an arithmetic progression? For that, find the common difference, that is, find the value of D. How we can find D? D is equal to T2 minus T1. First sequence, that's we already discussed, 2, 4, 6, 8, etc. Here T2 is 4. So 4 minus T1 is 2, first term. 4 minus 2. 4 minus 2 is 2. Now check with T3 minus T2. If the difference between consecutive term is constant, then only that sequence is in arithmetic progression. So T3 minus T2. T3 is 6. 6 minus T2 is 4. 6 minus 4. That is also equal to T. Check with T4. T4 minus T3. T4 is 8. 8 minus 6. That is also equal to T. For this sequence, the difference, common difference is constant. The value of D is 2 in case of all consecutive terms. So, we can conclude that the first sequence is in an arithmetic progression. Consider the second sequence 0.3, 0.33, 0.333, etc. Find value of D. D is T2 minus T1. T2 is 0.33 minus 0.3. 0.33 minus 0.3. That is equal to what? 0.03. Next, T3 minus T2. T3 is 0.333 minus T2 is 0.33. That is equal to what? 0.333 minus 0.33. What is its value? 0.003. And the value of D in case of T2 minus T1 is 0.03. And in T3 minus T2 it is 0.003. Here the value of D is not constant. That means this sequence is not in AP, not in an arithmetic progression. Consider the third sequence 127, 132, 137. Find the value of D. D is T2 minus T1. T2 is 132. So 132 minus T1 is 127. 127. 132 minus 127 is 5. Next, T3 minus T2. T3 is 137. 137 minus 132. T2 is 132. That is equal to 5. Here, the value of D is constant. That indicates this sequence in an arithmetic progression. Consider the fourth sequence minus 1 upon 5, comma minus 1 upon 5, comma minus 1 upon 5. Here the value of D is minus 1 upon 5 minus 1 upon 5, 0. In T3 minus T2, that is also equal to 0. Here the value of D is 0. The value of D may be positive, negative or 0. that sequence is in arithmetic progression. So we can conclude that the fourth sequence is also in an AP, in an arithmetic progression. In this way, we can find whether a given sequence is in arithmetic progression or not. Find the value of common difference, that is D. How we can find the value of D? D is T2 minus T1 or T3 minus T2 or T4 minus T3. And if the value of D is constant, that type of sequence is in arithmetic progression. The value of common difference D is T2 minus T1 or T3 minus T2 or T4 minus T3. That is the difference between two consecutive terms. In this section, we discussed about what is sequence. If numbers are arranged in a definite order, that is known as sequence. The numbers in sequence are represented using T. First term is T1, second term is T2, third term is T3, etc. If the difference between two consecutive terms in a sequence is constant, that type of sequence in an arithmetic progression. Or in arithmetic progression, we can simply represent it as using AP, arithmetic progression. To determine whether a given sequence is in arithmetic progression, find the value of D, and if this D is constant for that sequence, then that sequence is in arithmetic progression. Thank you.